Hi! So this video is going to be about contact generators in nbphysics. If you don't know what nbphysics is, it's a 2D physics engine that I made in GameMaker Studio 2. It's available on my GitHub. It's free to download, free to use on your projects, and it's actually going to be the physics engine that I'm using in my own projects as well. I'm using the GameMaker Studio LTS version, both for the engine and for this tutorial. But it should work with regular GameMaker as well. I haven't tested it though, so just a little disclaimer there. And if you'd like to download the tutorial code, it'll also be in its own little repository on GitHub as well. Here. All right, so let's talk about contact generators. So first, in a physics engine, you have rigid bodies or physics objects that collide with each other. So whenever a collision occurs, you essentially want to detect the collision and resolve the collision. So that's what contact generators help with. So if you go to the contact generator struct here, or this script actually has multiple structs. In this case, we have the general interface for a contact generator. In this struct, we have a function called addContact. And this function's job is essentially to fill out contact data for a specific contact. That includes things like the contact normal, which is the direction of the surface normal pointing from the collision. For example, in the case of a floor, the contact normal would point upwards. So this function's job would be to fill that out to make sure that that was detected. It also will return the amount of contacts that it detected and like filled out. It will also fill out a bunch of other contact data, and all that contact data is in this struct. So yeah, I mean, not just the normal, there's also which rigid bodies were in the contact itself. The restitution, this is basically how much it bounces off each other. One would be a high bounce, and zero would be like there would be no bounce at all. There's the normal, how much penetration was detected, along with let's see, this one is used for how much the contact resolver moved the rigid body. So that one you don't have to fill out, but these would be the ones that you'd fill out in regards to the contact generator itself. The next thing would be, and as you can see, there's a lot of different things that are that happen to like resolve the collision. There's a lot of things you have to do, but you actually don't have to really you won't need to look into that when you're using the contact generators themselves. And here's the resolver. This essentially resolves each of the contacts based off of the contact normal, everything that's filled within the contact data itself. And yeah, a little heads up as well. In a physics engine, at least in this physics engine, the hardest thing and the thing that might have the most bugs in it will probably be this contact stuff. There's a lot of things that could happen that like it generally like if you don't fill out the contact data correctly, things just won't behave the way that you would expect. So that's why it's really important to fill out your contact generators properly, I guess. Um, Another thing to note, how the contacts are even stored is within a contact structure or contact data structure in the physics world itself. So every physics world has a contact resolver along with the maximum amount of contacts that could happen essentially in one iteration. You can change that here. By default, the max contacts is 32, and you think that would actually be like, oh, that's a small number for physics world, but in reality, like within one frame, 32 contacts is actually quite a lot. And then on top of that, within that one frame, they get all resolved, and then The next frame, there's like 32 free contacts. So this does mean that it's potentially possible for, and it's very likely that uh, rigid bodies will be like intersecting in some form. But that should be fine. That's the whole idea of like your physics engine should be able to work with that happening. In fact, it needs to work with that actually happening. So yeah, that's a little bit of how it works under the hood. Now let's get into actually using a contact generator. So what do we have, right? Within the built-in physics engine right now, there's a couple of options. We have the general instance contact generator. So whenever you decide to make your own contact generator, you just have to inherit from the contact generator interface and then just fill out the add contacts, essentially. Everything here is like helper functions that are used to in the case of the instance contact generator, it's probably the most advanced one because it takes into account all of the shapes that are defined within the engine. In this case, this engine supports circles, rectangles, and rotated rectangles, which is these are the shapes that are essentially accounted for in this specific contact generator. Yeah, specifically. So if I were to say support other shapes, I'd have to add them here essentially. Yeah, but yeah, generally you would have to with the new contact generator fill this out. So this is what this one does, and it essentially goes through every single potential contact type, like rectangle between rects, rectangle between circle, and then rotated rect with all these. So yeah, this is already in the engine. You can use it as is. Uh, So yeah, this is the one actually I'll use right now, just to show you guys. But first, let's look at the other ones. There's other ones that are way simpler. For example, a link essentially simulates a contact. Well, actually, a link doesn't. A link is an interface as well that's used for a cable and a rod as contacts. So a link will essentially link two bodies together and returns a current length that is going to be used by these other ones to determine if a collision happens. In the case of the cable, a cable functions like a spring or like a bungee cord actually. Only for a bungee cord, when a bungee cord, let's check out the bungee cord real quick. When the bungee cord reaches a certain rest length, right? When it is bigger than the rest length, it'll calculate a force and it'll apply that force to the rigid body. The cable is very similar, but instead of applying a force via the spring force, it'll add a contact and it'll set up a contact based off of how far away the object is from the anchor point. In this case, whatever the other rigid body was, and it'll essentially calculate everything that's required to properly fill out the contact data. In this case, the rigid bodies. It'll also calculate the normal and how much it was penetrated. In this case, it's essentially how far away did it go from the circle of like a radius, and it'll return how many contacts were generated. In this case, it'll just be one. So yeah, that's how the cable one kind of works. Anchored cable, similar idea, except instead you pass in an anchor, or you pass in a position versus an actual rigid body. And the rod is exactly like the cable, only it generates contacts on both sides. So it like keeps it a single length. So yeah, this one is a little, it could be a little bit finicky because it could generate contacts like every frame. Well, it most likely will. Um, which is why there's a limit, or not a limit actually. There's a what's it called? A wiggle, which will sort of like you can adjust when you create it, It gives you a little wiggle room before it actually like creates a contact for it. So yeah, that's a bit about like other ways of making of types of contacts generators that you wouldn't necessarily think would be a contact generator. But let's use the one that's probably the most going to be the most used. So from this point on, we're going to have two rigid bodies, and they're going to collide, and they're going to resolve themselves using the instance contact generator. So we'll start first by checking out what we have right now. So in the previous video, we were doing force generators, and we ended with, I think this here. We have two forces here, the bungee cord, as well as the gravity force. So we'll take off both of those, as well as probably make the player smaller, and maybe change the color just so we know the which one's the player. It doesn't really matter, but that's what we'll start doing here. So I'm gonna go to the rigid body and the player, and we're gonna unlink these. For now, I'm just gonna comment it out, and yeah, we don't need. Actually, I'm not gonna comment it out. I'm just gonna delete it. Delete this one as well. We won't need to draw anything new. But for the player, just so we know what the player is, we're gonna draw little dots. So it's gonna be player dots. So we're gonna draw a circle, X, Y, radius of 2, outline is false. Okay, that'll be fine. We're gonna also, so we don't need to define these anymore. We'll keep the dampening because it doesn't matter. Everything here should be okay. This should also be fine. Okay, and we can go to the ball real quick and check. This also doesn't have anything here. Okay, let's see what happens. And let's make the player smaller. Is there? I don't think it's a set size. MVP. No, there's not. So to set the size of the player, we'll just change the image scale. So set size. Image X scale is equal to, I think it's already 1, so it's 0. Actually, no, it's not. It's because when we created the player, it's right here, I think. We stretched it. I'm pretty sure that changes the image X and Y. The scale here, right? So right now the scale is negative 31 by 25. So it doesn't really matter what we put here, but I'm gonna just go like 15, and then I'm gonna duplicate this. Oh, actually, that's how you do it. That's and Y, so 15 as well. And we'll see how that looks. Okay, it's fine. Maybe let's put a different dot because we're a bigger dot. Okay, so yeah, there you go. We can see there's no forces happening. We have I guess another like a ball here, and then we have a player, and they don't collide with each other. So that's just like the base that we need. But so what we want is when this player moves and hits this ball, it'll basically move either of them. Okay, that's the next step. So step 1, very simply, okay, what type of contact do you want to happen here? In this case, we want to have an instance contact generator to occur. We could, because this is such a general thing, something that most likely every object would like to have, we could put it in like a world object or like a general object, create it there, and then when on room start, we would just link it there. But because there's only 2 objects and it's like a demo, we'll put it in the player. So we'll create the contact generator here. So contact generator, And in this case, I'm gonna call it CG for contact generator, and I'm gonna call it instance contact generator. It's a new instant contact generator. All right, there you go. And on room start, here we linked the force generators, but instead we'll just link the contact ones. So go with O, in this case, we could go O player, but I'm gonna do for both of them. So they both inherit from rigid body. So I'm gonna go O nbp underscore rigid body. So both of these, the ball and the player, will have this happen to them. So we're gonna go nbp add contact generator. So this function requires a rigid body. In this case, it'll be self.id. So whatever rigid body is currently in the scope here, and then the contact generator itself, which would be other.cg instance. So this links all of the rigid bodies to this contact generator. So when we press play, or also just let's see what this does whenever you add a contact generator here. I guess I'll just play just to show you. So there you go. So this works both. So because both of these objects are circles, it does contact generation as if it was circle circle. But just a little example, I'm going to switch to different shapes and it should still work. So we're going to go rect. And as you can see there, push it in the corner, push it. So yeah, it's that simple. If you want to use the instance one, that's how you use it. Even if you rotate, it'll also account for that. So if I just go into begin step and just start, as long as you rotate with the nbp set angle, self.id, and then you go, just go image angle +1. So if you just rotate at every frame, it will still work here. So yeah, and then I'll just real quick show the rotated one, because these are the only shapes that are in the engine. So rect rotated. So there you go. Yeah, and that's for circles. And I guess we could also just might as well make this one into a different, just to show you that it also works for other shapes. So yeah, that is the contact generator for the instances. As long as you have the instances set correctly, the shape, and you create a contact generator, uh, this should work with those those shapes. An important thing with the sprites, just a little quick thing to note, make sure for that one specifically that the collision mask is rectangle. This is important because of how the collisions are detected and resolved within let's see CG or within the contact generator struct. It uses place meeting, and then it also uses instance place as well. And all. But yeah, generally, if you um, if you have one shape that's a rotated rectangle, it essentially treats all because okay, sorry. If you have a rectangle with rotation on any of your sprites, it'll treat all other sprites as rotated rectangles as well. So you would then miss uh, like contacts, like say here, because even if this was a rectangle itself, like because it uses the bounding box. So yeah, just a heads up there. Okay, sorry, that was a little tangent, but that's how you use the built-in instance one. Um, and I guess yeah, the cable is pretty simple as well. It functions very similarly in like how you do it with these. Okay, so we have an example, probably the most important one for contact generators. Oh, another thing I guess to note when you create, whenever you add a contact generator to a rigid body, similarly to a similarly to the force generators, it adds it to the contact generator array that every rigid body has. If you go to the rigid bodies here, um, here's where it's held. Okay, and also I just remembered because looking at this, um, you can use these for layer detection. So on top of whatever rigid body is used, because in the physics world, whenever a rigid body is being detected or like a collision, it uses the rigid body object here. So you can filter out specific rigid bodies by just changing this. But if you want even more like finely tuned like collision detection, you would change the collision layers. Let me see, go back to the rigid body here and here. So there's essentially each one of these is a layer itself. If there's a one on it, it has that layer. It's on that layer. So the collision, so the bitmask string is where it's where the rigid body lives. So all rigid bodies live on the first layer initially, and the collision bitmask is which one it checks. So it functions very similar to how Unity's collision layers are. So if you say you live on this layer, but you check on this layer, then you wouldn't detect the collision with yourself and kind of things like that. So that is collision. That's bitmap strings. You could, if you want to change, and just to give an example here. So right now the player is in the. They're both on the same layer and they both check the same layer. So if we change the layer here for the ball to a different layer, in this case we'll go change layer. So nbp sets. Actually, how would you? Is there definitely a bitmask layer? Hold up, hold up. There's definitely a function to change the general functions. Let's go here and move this over here. Let's go Control F. Bitmask. There you go. Oh, it's called set layers. That's what it's called. So nbp set layers. I'm pretty sure this returns. Actually, no, it doesn't. It sets the layers themselves. Okay. So going back to, let's see, where was I? So I don't need this one anymore. This one, cable, rod, bungee, any of those. Okay. Here you go. So the ball itself, if you want to change the layer of the ball, we'd go nbp or nbp set layers. Okay. So this one, you choose the rigid body itself. In this case, it would be the ball. Self.id. And then we do is collision. This basically is like, oh, are you changing or setting the collision layer where you're going to check for collision, or the regular layer, which is where you are. In this case, we're going to set the layer of the ball to be 0 so that it's not on any of the layers, so it'll like not be detected. So we're going to go false. It's because we're changing the lived layer, I guess, and then we'll set this to 0. So by default, the other ones are set to 0, but this one by default is set to 1. So we just have to change this one here, B1, to be 0, the rest will be 0, and then the, I guess you could print out the show debug message string, the actual bit mask. So also what this does whenever you like set the layers like that, it converts that into binary, and then it makes it into like into a bit mask. So yeah, okay. We'll just go here, press play. And when you walk in, oh wow. Interesting. So I guess there's a collision that's being detected here, which does mean that that's a bug, but generally it's supposed to be like this, where you just would not detect any collision. So that's something I'll probably fix. But yeah, okay. I'm curious actually if that happens with the with this being a different shape. So I was rotated rect with a rectangle. Oh yeah, interesting. So yeah, this one is actually not really functioning the way it's supposed to, because the actual bit mask as well is 0. Okay, so I would say for now hold off on that, but it should actually, you know what? Let me just set both of these to be 0. I'm curious what that would do. Oops, that's actually the same one both times. Okay. So now the ball is on no layers for nothing. Okay, there you go. All right, so that must mean that I'm probably mixing and matching the bit mask, which is not good. But yeah, that should be fixed later. Hopefully, when you're watching this video, it's fixed. But yeah, that's how you can potentially change the collision layers with bit masks. So you could, for example, have like the player that can interact with like coins, for example, but the enemies would be on a different layer and it would not interact with the coins. Okay, so that is the bitmask layers. What else is there? The last thing I'm going to be doing is making a custom contact generator, but I want to make sure that everything else is covered. So we're going to go click the rigid body here. Okay, bounciness. This you can change between rigid bodies depending. Oh yeah, actually that's pretty important to check. So right now, actually I have to remove this. So now back to normal. Okay. So now, right now, the restitution I think is a 1. Or actually, these are both bouncy. So when you hit, it's like yeah, it essentially bounces. Um, if you change the bounciness to the ball to be 0, it should be a lot less bouncy. In this case, you should set it between 0 to 1 normally, because it essentially multiplies whatever velocity happens by this number. So okay, it's still somewhat bouncy, but actually, no, I guess not really. Yeah, I mean, because it's still getting a force applied to it, so but the actual velocity itself should be lower. If both of these were bouncy, not bouncy, let's see what happens here. It should be way, because it doesn't average. So if the player was a bounciness 1 and the ball is bounciness 0, the bounciness of the contact would be 0.5. Okay, yeah, there you go. So if you just like slightly move to it, or just like a little bit. So yeah, okay. That's bounciness. You can obviously play with that. Curious actually, just might as well. Let's go bounciness to 4, and we'll keep this at 1. That should really push home. Yeah, there you go. That's really bouncy. Okay. So yeah, that's another thing with contacts. That also should apply to the links. Anything that's contact is, or not anything, but like yeah, any of the pre-built ones. All right, I think that is everything before we get to a custom. Oh yeah, that's really important. Oh my gosh. Okay. So let's go back to this and let's remove the rotation. Okay. Um, and the bounciness is back to normal, I think. Okay. All right, so contacts as well. Like, how is this force even, uh, like, how is it being determined, I guess? Like who pushes who, right? In this case, if I go like this, why does this circle move about the same as the player, or the player move about the same as like the circle? And that all has to do with masses. In this case, the forces are determined based off of the mass of the object. So if you want an environmental object, you would have to set the mass to be essentially infinite, or the in or the inverse mass to 0, either or. Because rigid bodies store the inverse mass, you can just set the mass to 0, and it'll make it an environmental object. So that's super important. So like notes, inverse mass equal to 0. That makes it infinite mass, and now the object should not move at all. There you go. Yeah. So this is another thing. Yeah, the boundiness would like apply to this. But yeah, there you go. That's how you would make an environmental object. And if you want to make something that's like pretty massive, but like not, you know, immovable, a smaller number means a higher mass. So it goes 0.05. And now this object would be like a heavy box here. You just like barely move. So yeah, super important to like note. But yeah, that's and another thing, I guess, I'm actually curious what happens here if I do 1. Actually, I can make it pretty heavy, 0.05. But let's make the player like an infinite mass. So that should make the player just straight up bulldoze through things. I've never seen this happen before. Oh. Oh yeah, okay. So that can't happen because you also move through forces. So because I set the mass to essentially infinite in the begin step, whenever a force is applied here, this the net force to the rigid body is affected by the mass. So the heavier it is, the less force it is. So if you would like to, in this case, you'd have to override the velocity by like literally doing velocity. But I would not recommend that because it would not. You would essentially be overriding like how the engine even works. But I'm actually curious what happens if I do that though. Also, that's set to be, in this case, it would be move input. We can set vector to be this, but then we also, this would be a force. Actually, let's go like this. Dot x. This is just like to test. I'm just really curious actually. Let's see. This will be a really huge number. So, actually, will it be a huge number? I thought it's a small number. Oh, okay, that's cool. Let's multiply that by a smaller number. Okay. So yeah, I mean, this if you have an inverse like a mass that's like really infinite, it'll still affect other things because of other things are getting resolved, but the actual inverse mass, the infinite mass object doesn't, it can't be moved back. So yeah, there you go. Okay. That's yeah, that's how masses affect the movements and the collision resolution. Okay, finally, we can get to the actual the custom contact, the custom contact generator. So say you want to make a custom contact generator. In this case, we're gonna simulate a floor. So you have a floor. We'll just like, yeah, just a floor that's all the way down here. If this player subscribes to that contact generator, whenever it hits a certain Y value, it will generate a contact upwards. So yeah, we'll do that simple one to show how to make a custom contact generator. And what's pretty cool about this one specifically is that no matter what shape I use for the ones that are here, if it's a rotated rectangle, a rectangle itself, or even a circle, all of them will have the same bounding box, I believe. Let me check this out. Let me see. If not, we'd have to. Oh, wait, what the heck? Wait, what is that? Let's see what this bug is. It's very likely not to reading suggestions. Did I delete that? I very likely deleted that. Oh, I guess I did. To do this. Actually, I don't even remember doing that. Okay. Okay. Let's go back. Make sure it runs. Okay. I took off the mass. Okay. Oh wait. I deleted. Damn, I deleted a lot of stuff actually. Okay. So this is back to normal. I think that's all fine. Okay. Let's see here. Okay. Very heavy object. Okay. Let's go. Oh yeah, I was gonna check. Oh, see, okay, it doesn't even matter what I did here. I'm gonna just real quick do this. Just want to make sure that the bounding box is the same. So yeah, that would be fine if the floor was here, regardless of either of these. The circle, the rectangle, or the rotated one would have the same floor. Okay, that's good. All right. So step one, just to get it set up, player. We'll add some gravity to them. So gravity dot y is equal to 10. See if that's the correct direction. And yeah, okay, it is. All right. So we'll have both of these have gravity as well. We'll just also just make this mass to be different. You know what? Might as well keep it like that, just to see what the difference is. Okay. Now that that's set up, when we press play, our goal is to define a custom contact generator on the bottom. Okay, it's infinite mass, so it doesn't get affected by gravity. All right. Our goal is for both of these objects. Wait a second. Oh, it's also asleep as well. That's actually an important thing. So it starts off asleep. We have to wake it up. Yeah, well, we'll just copy what we have here. Wake up. So start it off awake. Because gravity in this engine doesn't apply as a force, it applies as an acceleration. So yeah, there you go. That's why it doesn't wake it up. All right, our goal is to have a floor that pops up here. So let's get started. Step one, in a similar manner to the force generators, we're going to create a new script here. I'm going to make a folder first. Contact gens. I'm going to create a script. I'm just going to call it floor contact gen struct. So this will act as a floor. I'm going to go like here. close this as well. And I'm going to start off with the interface, so I don't have to write as much. We'll go to the contact generator struct here, go to the, yeah, here it is, copy it, paste it down here, copy this floor part. Actually, yeah, I'll do that. Then it has to inherit from the contact generator, so we're gonna go like this, take off this floor part, add the parentheses, okay. So we have a floor contact generator that inherits from contact generator. We don't need the top part anymore. I'm gonna change the JS docs here, and I'm gonna change the name here to be floor. Okay, let's go floor. Okay. So our goal, we don't need this anymore because this function's already in the contact generator. The only one we have to overwrite is this one. So here we are going to, so how this one's gonna, in my mind right now, is structured will be if a contact happens, right? Let's say contact happened, or I guess we hit floor. So we'll return one here, but we're gonna check for things first before we return one. So we're gonna didn't hit floor. Cannot spell. Okay, so we're gonna if some sort of thing happens here, then we return 0. There you go, because this requires that we return how many contacts we generated. So we have to have an if statement here, and if we get past this part, we're going to have to fill out contacts data. Okay, so to get it started, actually, we'll just start from the top here. So how are we going to even detect? So step one is collision detection here. So as we discussed, all the shapes are going to essentially function the same. If you had to account for different shapes, similarly to the, let's see, to the instance one, you'd have to figure out like the different situations based off of the shape itself. But a lot of contact images, such as the rod and the cable, don't even require specific shapes. So that similarity is also with the floor. So we're going to treat it all as if they're using the bounding boxes. So in this case, very simply, oh yeah, also, when you're defining a floor contact generator, you'd like to define the actual floor position. So we'll do, I guess, level. And we'll just make a level here. Or I guess, make it called height. It doesn't really matter, but I'm going to say height because it is less confusing, I think. So we're going to go param. This is going to be a real number. It's going to be called height. And it is the height of the floor in global coordinates. So it's not a relative height. So whatever this number is, it is a y value. Whatever value is right here, that's the actual thing. Okay, so we have a height here. We want to save the height to be used later and add contact. So we're going to go height is equal to height. And that is actually all you need for this one, I think. I'm pretty sure. You could have another. Actually, I might as well just because it makes it more interesting. A bounciness, which would be something you can also add. So you can go bounciness. And because maybe you don't want to like always do this, we'll just go equal 1. So it's like a default. And okay, write this as well. Here, duplicate this, go real. It's also here, this, and then how bouncy the floor is. Okay. Um, and you can just simulates a floor. All right, so this there's a bounciness will set default to this. Okay, I would say that's generally all we need for this one. Height and bounciness. All right, to get started, step one, the rigid body. We're only going to be using the bottom bounding box part, so that would be B box bottom. And we're just going to compare it to the height of the floor. In this case, I don't think we need any calculations here. Like, at least before, we just have to have the if statement here, I think. If the bounding box is, because y is positive here, it's going to be if it's greater than, and you could also do equal to, but it actually doesn't matter. If it is greater than the heights. Whoops. Huh. Height. If it is greater than the height, then, oh, actually, be less than. So if the floor is here, bounding box above it would be less, and that would be when you would return, you didn't hit the floor. So if the bounding box is less than the height, then you return 0, no contact happened. If it did hit, the great thing about this is that most of the information is actually going to be pretty easy to figure out. So here's where the actual stuff happens. So what do we need to fill out contact data wise? Well, we go to the contacts generator first, just to see what we need to do. So we go to here and we see we have a rigid body, normal penetration. So we can copy both of these. I mean, not both of these, all of this stuff here, and just paste it here. And we can go delete all this stuff, honestly. I mean, you don't have to copy paste this stuff, but I just don't want to type. And also, you also don't have to fill out some of these things. Actually, really, only this one you don't have to fill out because it's by default 1, which is fine. Restitution is the bounciness here. Okay, so we're gonna go rigid body 1 here is gonna be the rigid body itself that passed itself to this contact generator. Rigid body 2 will be undefined, so we don't have to do anything with that one. But yeah, I guess like that. So if it's undefined, it treats it as if it's a infinite mass, which means it doesn't do anything to it. Restitution here will be the bounciness that's passed in. The normal here, it'll always point upwards, so we can do either new vector 2 pointing upwards, or we could just go, actually that's probably the better way. So 0, -1 is in the up direction, and penetration is the only thing we really have to calculate. Oh, also, another important thing here, these aren't even defined in this struct. So how I do it in, let's see, instances here. When I fill out the actual information, let's go to circle. Okay, we have a contact itself, which is passed in here, but we figure out what contact here. Okay, here's the important thing. So the physics world, there's a contacts thing, right? And that's where you'd go. The index itself is, in this case, it is the next contact index. Okay. So that, yeah, it's probably not the easiest way to go about it, but first thing we're going to do is actually get contacts. So var contacts is equal to physics world dot contacts indexed at physics world dot next contact index. Let's just make sure that is what it's shown here. Yeah, copy it just to be sure. Okay, so this gets the current contact index, or the current contact position in the physics world, and this is the what we actually fill out here. So this contact has a rigid body one, it has a restitution here, it has a normal. On top of that, we also have to clear it as well, because these contact data are reused every frame, so we have to clear it as well. Contact.clear. I'm pretty sure that's what we use here, just to be sure. Yeah, clear contact and then do everything. Okay. So contact.clear. Yeah, the rigid body for the first one. Restitution is bounciness. Contact normal is upwards. Penetration, the only thing that we have to actually calculate, and it should be pretty easy. Whoops. It is going to be the height, because, wait, sorry. The bounding box itself is going to be positive. We're not positive. It's always going to be greater than the height. So if you subtract it, you'll get the difference, and that's the penetration. So yeah, that's it. Penetration, normal, restitution, and then return 1. So to recap, this floor contact generator, you pass in a height, which is a real world Y value, and a bounciness, which is by default 1. And whenever if a rigid body registers to this contact generator, it'll use this function, pass in itself and the physics world as well, and it'll essentially check its, oh, that's important. It'll check the rigid body's bounding box bottom and check if it is less than the height. If it is, I mean it's above the floor, it'll return 0. If it's not above the floor, then it has to be inside the floor. So we get the contact, clear it, and we fill out everything that's required for the contact data, and we return 1, meaning that we filled out 1 contact data structure, or one contact. Yeah, I guess. So yeah, moment of silence here. I think that's all we need. Okay, so we created and we filled out the thing. See, it's not too bad for certain types of contacts. So now all we have to do is register both the player and the ball. So similarly to how we did it with this one here, it's registered for this one. We can also register contact generator floor, which is equal to a new floor contact generator. Here we'll pass in room height, and we'll give it a little bit of a buffer, minus 16. Okay, and there's a CG floor, but even though we created it, we didn't actually link it, so we're going to link them all here. We're going to go nbp, similar to here, pass in ourselves, and other dot CG floor. Okay, moment of truth. We press play, and they should both stop. Nice, and something crashed. So let's check that out. Container, yeah, there's no such thing as bbox bottom in this scope. I thought I fixed one of them, but I didn't fix both. RB dot, there you go. That should be fine. Everything's good. Play it again. All right, and there's the bounciness as well. They kind of bounced, so that's pretty good. We could have this guy rotate as well, just so we can see that it works in real time. nbp set angle self ID again, and we're going to pass in our image angle +1. So that'll rotate, and then also, just so it looks nicer, we're going to also draw the floor on the player, which doesn't actually make sense, but it has the reference to the contact generator, so that's the only way. Okay, so we're gonna go draw a line. We're gonna go from this. So this is like not even. Honestly, the nicest way would probably be to inside this make its own little draw function. So we're gonna go static draw is equal to a function, and it's like a very simple function that'll just be draw a line. In this case, we'll always assume it'll be the room width, basically. So it'll be from 0, 0. Oh, sorry, that's not true, actually. It'll be 0 room or height, 0 or room width, and then height. Okay, so a line from 0 to room width, and the line is the height. Okay. So this obviously you can change to whatever, but this is just for a demonstration. CG floor dot draw. Okay. So we can draw the floor, and did I change the bounciness? I don't think I did. Let's go to the floor. Oh, the cool thing, yeah, see floor. Let's make the bounciness to 0. Oh yeah, there you go. So it's not bouncy at all, and the rotating rectangle collides with it like pretty well. So yeah, that is how you make a custom. That's how contact generators work in nbphysics. It's definitely like the longest video that I made. It's because contact generation is super important, and it's also like very prone to bugs. So when I'm working on the engine in the future, I'm gonna be improving this aspect of it, this area. So yeah, in the next video, I'll be going over triggers. Those are essentially like rigid bodies, but they're way simpler, and rigid bodies can essentially detect when they're inside of a trigger. If you're interested in that one, you should subscribe or check out that. And yeah, I think that's it. Have a good day.